Welcome back. Let's move on to the next problems. In the relation x greater than y plus z, x plus y greater than p and z less than p, which of the following is necessarily true? Okay, let us write the inputs one by one. X greater than y plus z, next is x plus y greater than p, and the last one is z less than p. Let us check the options one by one. Relationship between y and p. So we cannot find the relationship between y and p directly without knowing the value of x and z. Okay, therefore we cannot say anything about the first option. Next one is x plus y greater than z. So if you see these two conditions, that is the second and third equation, we can say x plus y is greater than p, and here again p is greater than z. So this is greater than z. Therefore x plus y is always greater than z. So the answer is option B. Next question. Let n be a natural number such that 1 by 2 plus 1 by 3 plus 1 by 7 plus 1 by n is also a natural number. Which of the following statements is not true? Okay. Let us write the given expression. 1 by 2 plus 1 by 3 plus 1 by 7 plus 1 by n. Okay. Here we can write the first three terms together. So the denominators will have an LCM of 42. So the numerator will be 21 plus 14 plus 6. So the whole plus 1 by n. So this will be equal to 14 plus 6 is 20. 20 plus 21 is 41. 41 by 42 plus 1 by n. So they are saying the whole sum of these numbers is also a natural number. It means 41 by 42 plus 1 by n can be equal to 1 or 2 or 3. It can keep going. So if we see, we can assume this value will be equal to 1. That is 41 by 42 plus 1 by n is equal to 1. This is possible only if n is equal to 42. That is, the numerator will become 41 plus 1 and the denominator will be 42. So the whole value will be equal to 1. Therefore n is equal to 42. If we see the first option, 2 divides n. This is true. Second option, 3 divides n. That is also true because 42 by 3 will be 14. And similarly 7 divides n. This is also true. The only option left out is n is greater than 84, which is not true. So the answer is option D. Okay, if you further investigate, this whole term will not be equal to 2 or 3 if n is a natural number. So if it is more than 1, then n cannot be a natural number. It should be a fraction or a decimal number. So you can check for yourself. You can substitute the value of 2 here and find out whether n is a natural number. Okay, the answer for this question is option D. That is, they are asking which is not true. The answer is n is greater than 84, which is not true. Okay, we shall go to the next question. A number when divided by 114 leaves remainder 21. If the same number is divided by 19, find the remainder. Okay, before we proceed to start solving the problem, let us revisit the terms in division. For example, 11 divided by 2 can be written as 2 here, 11 inside, 5 2s are 10, balance is 1. So this term 2 is the divisor and this term 5 is the quotient and this number 11 is the dividend and the balance 1 is the remainder. So therefore this dividend is equal to product of quotient into divisor plus remainder. That is, dividend is equal to divisor into quotient plus remainder. Okay. So with this understanding, let us start solving the problem. So here they are saying the number when divided by 114 leaves remainder 21. Therefore the number n is equal to product of divisor and quotient, that is 114 into, let the quotient be q, plus remainder, that is 21. So whenever this type of problem is given, we shall try to factor 114 by 19, that is 114 divided by 19. So 9 into 6 is 54, therefore 19 into 6 should be equal to 6 9s are 54, 5, 1 6 is 6, 6 plus 5 11. So this will be 6 times. Therefore 114 can be written as 19 into 6q plus 21 can be written as 19 plus 2. Whenever this kind of problem is given, we have to split the bigger term in terms of 19 or the second term given here. We can take 19 common, therefore 19 into 6q plus 1, that is we are considering only these terms, then the remainder will be 2 here. Therefore if you see, the number can be divided by 19 and the quotient will become 6q plus 1. Originally the quotient is q, now it is 6q plus 1 and the remainder is 2. So this is the new remainder. So the answer is option B, 2. Next question. 98th term of the infinite series 1, 2, 3, 4, 1, 2, 3, 4 and this keeps repeating. This okay. Here we have to find out the 98th term. And if we observe, the numbers are repeating after every fourth number. Therefore, this should be a multiple of 4. So to find out the 98th term, you have to check the multiple of 4 near 98. Multiple of 4 lesser than 98. So if you see here, 100 is a multiple of 4. The next one will be, that is the next lesser one will be 96. So 96th term will be having 4, 97, 98. This will be repeating. So this is 1, this is 2, and again it will be 3, 4. It keeps going on. So they are asking the 98th term. This will be 2. Answer is option B. Okay. Next question. Which of the following is a prime number? So we have to find out the numbers which are not prime and we have to find out the answer based on elimination. So the first option is 1, 4, 3. This is not divisible by 2, not by 3. But if you see here, the sum of the odd terms is equal to sum of the even terms. That is 1 plus 3 is equal to 4. So this means it is divisible by 11. Okay. Next we shall take 289. So this is equal to 17 square, which is well known. Therefore it is not option B. Next is 117. This cannot be divided by 2. Next is we shall check with 3. So 7 plus 2 is equal to 9. So this is divisible by 3. So the left out option is option D, 359. So this is the prime number. Okay, we shall continue in the next lecture. Thank you.